Okay, hello everyone. This will be a lesson about the transformations of trigonometric functions. So we are going to um, demonstrate here what are the effects of the different transformations. So we will use the sine function for this. Okay, this is the a basic sine function. So y is equal to sine x. Now we will be introducing some transformations, and we will observe what are the effects. So first and foremost, let us introduce the period and the amplitude. So this is the amplitude is the maximum and minimum points reached by the graph, and then the period is from 0 to 2 pi. That is um, the original period, the normal period of the sine function. Okay, let us introduce some transformations. So what if we multiply 2 to sine x. So as you can see here on the left side, we have here y is equal to 2 sine x. So let's see what will happen. Okay, so as you can see here, the one that was affected is the amplitude. Okay, if we multiply sine x by 2, so as you can see here, instead of pi over 2 1, it became pi over 2 2, and also here. So the amplitude is the absolute value of this the distance right here. So it can be positive and it can be negative, right? So since we're after the distance, let's just use the magnitude and get the absolute value. Okay, so that is the effect of multiplying uh, real number by sine x. Okay, so what if we multiply 0.5? So let's see what will happen. So as you can see, it decreased the amplitude. Okay, so that's it for the amplitude modification. So what if we multiply it by -2? Still, this will be an amplitude modification, but instead, it also reversed it. As you can see, instead of positive 1 here, it is already -2. So as you can see here, if you want to calculate the amplitude of the given function, you just take a look at what is multiplied. As you can see later, we will have a convention for this in the later examples. Okay, so let's just proceed for now with the different transformations. Okay, so what if we want to modify the period, not the amplitude? Let's see, if you want to multiply the period, you multiply a certain number to the x itself. So instead of 2 sine x, we multiply sine 2x. Okay, so if you do that, as you can see here, the period is changed. Instead of from 0 to 2 pi, which is one normal period, it became 0 to pi, right? Okay, 0 to pi. Okay, so because in order to calculate also the period given an equation, you need to divide the normal period, which is 2 pi. You divide it by this factor right here, this 2. Okay, so this will be, we have a convention for this in the standard form. This is b, this is called b. Okay, so that would be 2 pi over b here, which is 2. Okay, so that is how you modify the period. So what if we multiply what if we multiply a number lesser than 1, let's say 0.5? As you can see, if we divide 2 pi by 0.5, we get 4 pi, right? So as you can see here, the period is doubled from 2 pi to 4 pi. Okay, so let's take a look at another transformation, which is called a phase shift. So phase shift is a horizontal shift of this sine curve right here. So how do we introduce a phase shift? So we use this y is equal to sine is equal to x plus or minus 2. Okay, so if minus 2, it will be a shift to the right. As you can see here, it is a 2 units shift to the right. Let's say we want -1. Let's see what happens. Okay, so 1 unit shift to the right. So let's try a +1. See what happens. Oh, +11 also instead of +1. So that will be a shift to the left. Okay. So you need to take note of that. So if it is minus, then it is to the right, and if it is plus, it is to the left. Okay, let's stick with minus for now. Okay, so there you have it. This is the phase shift. Okay, so let's say we want to combine these different effects. Let's say we want y is equal to 2 sine 2x minus 2. Okay, so let's say let's stick with y is equal to 2 sine 2x first. Okay, so what happened here? The As you can see, the amplitude doubled, right? Amplitude doubled, and the period is divided by 2. Okay, so the amplitude is uh, now 2 instead of 1, and then the period is now pi instead of 2 pi. Okay, so let's say we want to introduce a phase shift to that. Let's say we want 2x minus 2. So based on what we've learned about phase shift, what do you think the phase shift will be here in 2x minus 2? So do you think this will be a 2 units move to the right? So let's see. So as you can see, this is instead of having um, 2 units move to the right, it only moved 1 unit, because in order to calculate the phase shift, you actually have to divide this to, if you have a b here that is not 1, so you have to divide 2 divided by b. Okay, so you have to do that, 2 divided by b, and you will see this in later examples as well. So this is actually b multiplied by x minus c. So c, in order to get the phase shift, you need to divide 2 by whatever is in here. So okay, so that's it for the transformations. There are more transformations, of course. We can also uh, shift vertically, just like any other function. Let's say the original function, we add 2 to it. So as you can see, we added a positive shift upwards, okay, in the y direction. Okay, so those are the different transformations that are very common in this um, trigonometric functions, or for any other functions. So I hope you learned something in this video, and we definitely will be using the concepts in this video in order to answer different exercises. So okay, so thank you for watching, and see you in the next video.